See that crack that you can see in the lava? How do you think that got there? Well, I'm going to tell you how it got there. Recently there's been a lot of earthquakes in this area. Do you want to know why? Because there's a volcano erupting just north of us. So as these earthquakes were happening, the reason behind the earthquakes was because magma was seeping through the crust. Now magma's buoyant, it wants to get to the surface, it's lighter than the surrounding rock, so it will shudder the earth and try poke through little cracks here, there and everywhere, and then eventually gets to the surface. But as it does this, it causes shudders in the earth, these earthquakes, mini earthquakes between a magnitude of 0 to 5, right? Okay, so that's how that crack got there. Last year I was here and that was not there. It was just lava. Now there's a big massive crack along the lava field and it's class. Also that's a lightsaber, you'll find out why later on. Welcome to the next episode of the Geology of Iceland, where I take you on a trip with me and we do the first hike of the volcano. See over there. One last hill. Now this is the first time that I have ever seen a volcanic eruption in person, except from on a helicopter, because a few weeks before I was on the helicopter. And as you can see, it was a very emotional time for me. I was greeting, which means crying in Scottish. It's amazing to see Mother Nature do its thing. Absolutely beautiful and fascinating to watch. And I'm so lucky that I got to see it. Hopefully I'm not standing in the way of the volcano. Right, okay. Right, what's happening, guys? Look at where I am today. I'm at the bloody volcano, that thing that I greet about. Okay? Now we're going to talk about how this thing forms, and we're going to talk about how the island of Iceland is formed, okay? Now the first reason why Iceland's here is because it sits at the mid-oceanic ridge. It's a divergent plate boundary, which means that the two plates are pulling apart from each other while they're pushing at this plate boundary, okay? And the plates are going out the way, right? So Scotland was actually situated where Iceland was 65 million years ago, so we had volcanoes like this once upon a time. There's evidence for that in the rocks that you can see today. It's pretty cool, okay, right? But anyway, back to Iceland. So, because you've got this rifting happening, you've got a partial melt of the mantle. So, mantle's made of a rock called peridotite. It's actually a solid, and every now and then it partially melts. And when it partially melts, it rises up the way because that partial melt is lighter than the rest of the mantle, so it wants to go up. It's buoyant, it's light, it wants to move up, and it hits the moho, like the bottom of the crust, and it will start moving up through the crust. Now sometimes it can crystallise at certain sections in the crust, so it can crystallise as magma chambers where the crystals are a little bit bigger, like as sills, as dikes. Basically it can crystallise as intrusive igneous rocks, but when it reaches the surface, it becomes an extrusive igneous rock, okay? It becomes a lava, right? So, it wants to get to the surface, that's its main goal, so it'll do anything to get there. And they actually knew that this thing was going to erupt the week before because there was earthquakes. Like, the seismic readers in this area were picking up earthquakes, and they could feel that there was something happening, like, within the ground, and that was like an indication that this thing was going to erupt. So it's quite cool and interesting for volcanologists, right? But as it seeps through the crust, it causes like cracks to open up so it can get to the surface. It shudders the earth a wee bit, and then all of a sudden it pops out and it forms what's known as a fissure. Now this fissure is usually a long stream of lava. It's like little wee fountains of lava that come out, and this is basaltic in composition, right? Which means it's made of like olivine, pyroxene, and minerals such as plagioclase, but the plagioclase crystallises a little bit slower than the olivine and the pyroxene, and the plagioclase causes phenocrysts. Sometimes you can see the phenocrysts in the lava, and hopefully when we actually go down to see the lava you can see this. But basically it pops out the ground, and it's known as an Hawaiian eruption, so it's quite gentle, like fountain-like, so it's not a Strombolian eruption like Mount Etna or or like Mount Vesuvius, it doesn't just go boom, it just goes like this, right? Like what you can see in the background, which is pretty cool and interesting, okay? Now, the second reason why Iceland is here, because when you look at the rest of the North Atlantic, you can see there's no other islands at the mid-oceanic ridge, so there must be another reason why Iceland sticks out the ground and you've got this island here, okay? And that is because there is a mantle plume under Iceland, and there's evidence of this mantle plume moving with the crust. Now, there's a few areas where there's mantle plumes across the world. You get them in Hawaii, you get them in the Tenerife, like the Canary Islands. They're formed by a mantle plume, right? So this mantle plume feeds magma from deep down within like the mantle, and it's causing like obviously more like magmatic activity, as well as the Riften Valley that you have here, like the Riften setting that you've got the mid-oceanic ridge, plus this mantle plume has caused this island of Iceland to form at the surface, and that's why it's here. So Iceland's main body is 70 kilometres thick till you hit the mantle, and then the outer edges of Iceland are between 25 to 30 kilometres thick, so it's quite cool how as it's moving away, like obviously erosion and that will eat away at the sides unless there's more eruptions that happen in Iceland, but aye. And this is what the lightsaber was for. I'm a big Star Wars fan. I decided to dress as Rey. I even got my lightsaber through like security at the airport. I don't even know how I did it, but aye. That is basalt. I'm not sure if you'll hear me, but this is basaltic lava. 1,200 degrees Celsius. You know how I was going on about the bubbles? Those are the little bubbles, the vesicles that hold the gases. And then as well you have little bits here and there. Alright, what's happening, guys? Look at this monstrosity. Look at that. That's what forms when your magma reaches the surface as a lava. It crystallises. Now, it crystallises very, very quickly. And that's why it's so fine-grained. But sometimes you can see certain textures in the lava that form depending on how quickly it crystallises, right? And how it crystallises, okay? So, these bits are all jagged edged. They're called aha. It's a kind of Hawaiian term. I cannot remember for the life of me what it means, but I'm guessing that if you step on it, you'd go aha. And you know how, like, they keep saying to people, like, how dangerous it is to actually walk on this stuff. You don't know what's under that. It could be, like, lava flowing under it, like, over there, right? And there's people been walking on this. I can feel the heat from this because over there's a volcano, right? And it's erupting, spewing out lava, right? And it's filled in these big lava fields, okay? This is the youngest rock I've ever seen in my life. Not even a week old. And I get to touch it. I get to cuddle it. I don't really know if I want to cuddle it because it looks a bit short. But well, look at you. Oh, you wouldn't want your hand on that. Fuck, imagine your foot fell through that and cut your leg open. You'd be fucked. Absolutely stunning. It's a beautiful day. Lava.
Look at the lava crystallising. I should have brought bloody marshmallows. So I had a wee incident with my drone. It's in the volcano. But it was totally gonna happen, you know. That's what it's all about, you know. But aye, fresh lava. A week old that is. That's a week old! I kind of shouted that out. Hopefully no one can understand my accent. Honestly, this has been the best day of my life. Look at all that sulphur depositing itself on top of the basaltic lava. Wow. Now that is due to the fact that the sulphur's actually coming through the ground here, seeping up. There's geothermal activity still in this area, so it seeps up through the ground and deposits itself as crystals at the surface. It's looking pretty good, man, pretty good. Also don't eat it. I've never been so happy to be back at the car, and I can't even talk. I'm sweating, man, I'm sweating. It's like fucking 20 degrees Celsius outside, Jesus Christ. And I'm wearing like bloody fucking 4 layers. Anyway, it was such a good experience, you know. Such a brilliant experience to see that volcano. Let's take my